Alright guys, so today we are in my house. This is the house that I'm living in currently, and I'm trying to sell, and I need a reliable heat system in here. Right now I have hydronic fan coils and I have a wood stove. I'll explain more of that later, but right now I'm going to install a radiant heat system inside the joist. So this house was built in 1890, and excuse the mess, but right now we are in the process of moving, fixing things up, selling, and building a new house all at the same time. So I'm going to put a radiant panel right here. This is going to be the main control panel for all the different components. I've never done this before, so we're going to kind of learn as we go along. So I'm going to put a 4x4 sheet of 3/4 inch plywood, Tapconned in. This is a foundation right here, and there's 1.5 inch foam here. So I'm going to put 3/4 inch plywood on. That way I can hang everything off of that. This is actually the addition that I built on my house, and the rest of the house was built in 1890. So this is kind of where we went through. This is the old foundation from 1890. There's no rebar, there's just big rocks in it. It's 13 inches thick. I have a zone valve controller, and I also have a switching relay, and I'll show you guys what they are in a minute. So remember guys, I'm still learning here. I'm gonna switch this around a little bit. I think it would be better if these loops were facing up. I did some research briefly before I put these on here, and I thought the consensus was that you couldn't put the manifolds upside down, but then I was seeing that there's a lot of people saying that you can. So we're gonna switch it so it can go upside down so that the loops can just go straight up, instead of what I was gonna do is go like this and then up with a bunch of loops going around. But it would be better if it could just go straight up. So let me get that switched around. I guess this would be a good time to start explaining what's going on here. So basically, this radiant heat system is going to be a little bit more complicated than normal. I'm going to be using what they call an indirect water heater. And basically what that does, this is the inlet and outlet of the heating element on the bottom. So you send water through it that's hot, and it warms up the rest of the tank. So this is the hot side of the radiant loops, and this is the return. And then this is the in and out for the water that heats it up. So the boiler would feed these lines right here at a temperature that's higher than the tank, which in this case I have a tankless boiler combination domestic hot water heater, and it sends out 176 degrees Fahrenheit of water. And so basically what I'm doing is I already have fan coils in this house. So this is one of my fan coils right here, and basically you can see it's just like a car radiator with a fan, and then it's got two hex lines coming in and out, and then it goes out to these ducts here, and this is for my first floor. This little thing with 1/2-inch PEX does the whole first floor, and then I also have one on my second floor too that's a little bit bigger, and that controls all 4 rooms up there. And so rather than bring ductwork up to the second floor, all I had to do is bring some 1/2-inch PEX, 2 pipes up there, and that's it. And I got heat for the whole second floor. So what I want to do is keep that existing situation that I have going on with that. But the problem is I need to run that at 176 degrees for those fan coils to really make a big difference. If you run them at the radiant loop temperatures, which is like between 90 and 110, they just don't put out enough heat. So basically what I'm going to do is come in. This is going to be my zone right here for the radiant heat. And then I'm going to have 2 other zones, one for downstairs and one for upstairs. Right now, the way my system is, it's all on one loop and it always runs all the time. And I have Aqua Stats upstairs and downstairs as well as thermostats. So I kind of have it separated, but they're not on separate loops. So the water is still being fed to the upstairs at the same time as it is the downstairs, even if only the downstairs is calling for it. So I want to separate those so that if the downstairs is calling for the fan coils, then it does so separately, and the upstairs separately, or both at the same time, whatever. And then I have another one for the radiant loops. Okay, so then I'm going to have 3 loops in this manifold. It's all one zone, but 3 loops of about 225 feet apiece to do all the loops in my basement, in the addition as well as the kitchen, dining room, living room, and bathroom. But the water is not going to come from here directly into here. It's going to go into this tank first, and it's going to heat up the tank. And then when this thermostat for this zone calls for heat, what it's going to do is start taking heat out of the rest of the tank. And that way my boiler is not running every time that this is on. All it does is heat up the temperature of the water inside of this tank until it's up to temperature, and then it sits until that temperature gets below a threshold. And in the meantime, this radiant heat could be running non-stop all day, and my boiler only turns on once in a while. So that's the whole purpose of putting this tank in here. I got this tank on Marketplace. It's a 40-gallon indirect water heater. And what's funny is I went to go get it, and the guy said that he's actually a fan of mine. He watches my channel. But I got this for $100, and I don't even know how old it is, but I figured these things can't really go bad because there's no moving parts in it. All there is coils of copper in the bottom, and then it's just a tank. So the only thing you can do is get it plugged up, or it can spring a leak, I guess. But other than that, nothing else can go wrong with it. This is an Aqua Stat. That basically tells me the temperature that's inside the tank, and that's basically going to tell this loop to turn on over here, and then that'll feed it. Inside my boiler I have a circulator pump, so whenever one of these three zones turns on, it turns on that circulator pump automatically, and it also has like an expansion tank and air purge valve and all kinds of stuff. So it's got all that already. So I'm running two different systems really. And the reason I had to do it like this is because I don't want 176 degree water to sit in that tank all the time. I want like 110 degree water to sit in this tank. Because the hotter it gets, the more it can dissipate the heat, and you lose energy like that. So rather than have 176 degrees sitting in there, I'll have 110 degrees sitting in there. And that's much more efficient. But yet I still have my 176 degrees for these other two loops for the rest of the house. Which really, when this radiant heat is running, these really should only turn on like when it gets maybe really cold. Then the upstairs will have to turn on, and the downstairs could turn on if you say you have it off for a while and you let it get cooled down and you want to raise the temperature like 10 degrees all of a sudden. Well, then that fan coil can kick in and kick that temperature up a lot faster than that radiant heat can. So that's kind of the pros and cons to everything. The radiant heat takes a while to warm up, but once it's warmed up, it's very comfortable, and you can actually leave the temperature lower. But the fan coils will heat it up a lot quicker, and therefore you can feel comfortable faster, which I don't really care about, but I'm selling this house. I want people to have some options in this house. Radiant heat is definitely sought after for a lot of people that are buying a house because it's a nice feature for a house. So I got to take some of this old piping that they have on here off and switch it around to PEX, and I'll get all this hooked up, and I got all kinds of parts, so we'll go through one at a time. If you guys are wondering why I'm doing this with a used tank, these tanks start at around $800 for the cheapest one, and then they go up from there a lot. So since this isn't really the primary heat of the house and it's kind of an experiment, that kind of justifies getting this tank instead of a brand new one. And I don't have all my tools with me, so I'm using stuff that I have around here. Even though I don't need a ball valve on here, I'm just going to keep this the way it is, and I'm going to adapt this to 3/4 PEX. This is the loop that's going to go in and out. This is actually meant for domestic water, so that's why this is a 1-inch loop here, and that's a 3/4 loop there. So I also don't need a TMP valve, temperature and pressure valve here, so I'm going to take that off and just come out of here. Let me explain what I have so far here. So, coming out of the tank with the hot water, coming up into, this is what they call an air purger. And basically what it does is it allows the water to go upward in this upper chamber here, and that's where you can get the air out of all the lines. And this is an air vent. This automatically lets air out, but not water. So the bubbles from the air kind of collect up top here, they make their way up to here, and it vents out of here. That's how you get the air out of the system. So on the bottom here, this is a 2.5 gallon expansion tank. This is a small system, so this is plenty for this. And before I even go any further here, on the expansion tank coupling here, there's like a port for a boiler fill valve right here. This is what they call an autofill. So basically what this does, this right here is a gauge, and you set it to whatever pressure you want the system to run at. It's automatically set from the factory to 12 psi. So basically what this does is it takes your regular cold water from your house and it injects it into the system in order to keep it up to 12 psi. So a lot of systems, they'll lose a few psi over a few months, and I think it's because expansion and contraction and stuff, but even if they're not leaking, they do lose pressure. So this always keeps it topped up. And this is also a backflow preventer. So in other words, the flow can't go backwards and contaminate your domestic water. So now, following the flow of the water, it's going to come over here to an isolator valve. This is an isolator with a swivel on it, so you can swivel this flange. That's always nice. Not every one of them has that. This is also where you can fill the system if you want with antifreeze. I'm not even going to use that. I probably didn't even need to get this kind of isolator valve because they are kind of expensive. Just a regular isolator valve would have been fine. And then even after the circulator pump, I think just a fitting coming out, I probably didn't even need any of this stuff. This is a drain right here, just the same as this. I just face it down for a drain. So this valve isolates the drain, but this valve up here just shuts everything off. This is a small circulator pump here. It's got 3 speeds on it. It's not an ECM pump. I'm already kicking myself in the butt. I should have got an ECM pump. They're a lot more efficient, but this is what I got. I didn't really know a lot about these pumps. Then finally, after the circulator pump and isolator valve, we have a 3/4 PEX tube, specifically meant for radiant heat. This has an oxygen barrier in it. Regular pipe does not have that, so you can end up with air in your system just from the pipe, from expanding and contracting. Okay, so now I'm ready to install my 3 loops. And they're about 225 feet a piece. There we go. That's good.
This out there.
Good. Alright, so all of the tubes and the plates are run. And you'll notice that in here, because this is 16-inch on centers, instead of trying to loop around right next to it, that's too tight of a bend for my liking. So you kind of skip every one and you go around and back and around and back. So then down on this end, just have a loop to go back. So really all you need is one set of holes going down this side, and then I got my return pipe right here, which can kind of go through the middle. That doesn't need plates or anything. Actually, that's a mistake. That's not the return pipe right there. That's actually going to be the first part of the run. So this goes down over here and starts on this outside wall and works its way back, up and down, and then next to the boiler here is actually going to be the return. The end here, this is the return here. All of the loops in the rest of my downstairs are run too. Everything is all done. Remember, this house was built in 1890, so these are joists that are like, what, 130 years old. So it's not exactly easy to do this, and it's been sitting here for a long time, so it's got dust and everything. So now we have 6 tubes to hook up for the 3 loops that's on one zone. So let's get those hooked up, and then I'm going to get water running through that system, and then we'll hook up our primary system. This is a secondary, this is a primary. I'm going to use this hanger and put it right here. That way all of them can flow nice and even, and they're guided. So that may not be the prettiest, but that works. I almost think the better way to do this though is to overlap these so that you only use one screw for each side of this. So you only use half the screws, and that'll bring them in closer. That way they're not kind of like spreading out at the top. But it's fine. I'll just make note of that for my next install. It's fine for this one. So at this point I'm ready to start putting some water in each of these loops separately. They're not getting any actuators on them, so this is what controls it. This is what turns it on and off. Just a knob here that you turn. Basically that thing right down there. As you're turning it, pushes in this little pin right here. And that pin, when you push it, it closes the loop. So you can see on this one, when I push up, you can't really see it that well, but it shuts everything down when you push it up. So with that in mind, I'm going to close all of them and just open one. So these two are closed. I'll just work with this one. So the first thing I'm going to do here is charge the system with water, the secondary system here. So what I realized that I didn't know before was this is a fill valve right here, but this is also an auto fill valve right here. I didn't realize that this came with this assembly already. So I already tried to feed it water and it wasn't making anything happen. And I figured out that's because this is only giving it 12 psi and this is looking for 15 psi over the charging pressure. So this is also set at 12. So 12 plus 15 would be 27 pounds of pressure that I would need minimum just to be able to charge this. So this is only giving it 12. So let's eliminate this, and we're just going to hook the water right up to here. And I'm going to use this on the boiler side because I actually don't have an autofill valve. I have a manual fill valve on that. So when the pressure gets a little bit low, I got to top it off. So we'll add this to the boiler side and we'll leave this on the radiant heat side. So while that tank is filling and the loops are filling, I'm going to start getting the electric hooked up. So right now I got one loop opened up and I'm getting all the air out. You can actually hear it. I got the pump on high speed. I'm just going to keep purging it until I get all the air out of that loop, and then I'll close that one and open another one. You can see I'm getting a little bit of flow out of the flow meter. It's kind of hard to tell, but getting like a half a gallon a minute. Once the first one is done, I think that the other two will go a lot quicker, because then you're just getting the air out of the loop, not the whole tank and everything all in one. Alright guys, so I'm switching gears here. I'm going to come up with a different plan here. So instead of coming out of this manifold and into that tank to heat it up, and then the top floor and the bottom floor fan coils, what I'm going to do is just do the top and bottom floor fan coils. I'm going to leave one of these zones open, and then what I'm going to do is put a zone valve somewhere on this board that's separate. That way I have 3/4 PEX going from the boiler to the tank. And ideally, I guess I could have bought a 3/4 manifold and then just reduce it down for the 1/2-inch lines, but I didn't, so I'm just kind of working with what I got. So I had to buy a zone valve that's about $120. So let's get that hooked up and let's get this tank heated up. So this is a zone valve I have, and it's got sweat fittings on it, so we need to sweat some copper onto this. I don't do a lot of sweating. I always try to avoid it. The rest of the system has no sweating. I do a lot of plumbing work, but I always avoid doing the sweating. I always use either PEX crimps, cinch rings, or I do like these are the lock-in type, and then I also do like threaded pipe and stuff. And usually you can always get away with that. There's very few times that I ever have to sweat anything. But let's go ahead and sweat these pipes onto here and we'll get this hooked up. Alright, so now I'm ready to hook these up to the boiler. I teed off with 3/4 to the zone valve, and these are going to be 1/2-inch manifolds for the fan coils. Two of these fittings are missing, the EK20 to 1/2-inch PEX. I just ordered a 10-pack. I didn't realize I actually needed 12 of them. So luckily this loop was kind of a bonus loop. And what this is a kick space heater underneath of my kitchen sink. So I was going to put that on the same zone as downstairs, which is this one. Which means there's going to be an actuator on each one to open them up, but they're going to be linked together to open up at the same time. And then this is going to be my upstairs loop. But I don't need my kick space heater right now, so I'll get that ordered and put that in a couple days. All I gotta do is put the fitting in. So for right now, I'm ready to manually shut off this zone valve right here, just because I don't have it hooked up yet. I'm still kind of trying things out. So just a little manual release. So what I did is close the ball valve there. So now it's not gonna feed the tank when I turn on the pump in the boiler. So what I'm going to do is turn on that pump, and I can actually do that without even firing it up. And then, so what I'm going to do is just get the air out of each one of these lines. And as I'm getting the air out of those lines, I'm going to go ahead and hook up all my thermostat wires and anything in the 120 volts that I need to bring into this other Taco valve control system. Okay, so the water's all purged out of both of these lines right here, and we'll get this one later once we get these little fittings. So now let's put these zone valves in. So these are just the manual little knobs that it comes with, so you take those out. I'm going to leave the manual dial in there just because I'd feel better, because if that opens up for some reason, this is going to spray out water. So let's get these hooked up. They go right over here. This is going to the boiler just to tell it to turn on, which also turns on the pump inside the boiler too. This is an isolated end switch, which means that since all the zones are going to turn on the boiler, you don't want to turn on one zone and then it turns on basically the thermostats on the other zones. So it's isolated to each zone individually. Turn the priority off. What that does is it makes zone 3 a priority, so if all 3 of them are calling, it'll only let zone 3 through, which there's a couple different applications where that's really nice, but I'm not going to use it here. This boiler is 200,000 BTUs, so it has no problem running all 3 zones at once. I got a multi-stage thermostat, so these 2 wires are coming from the thermostat that are going to power the fan coils. I'm going to set that as the backup heat on the thermostat, so it'll be the 2nd stage. That's going to open up this actuator right here. This is to the thermostat for the upstairs, zone 2. Zone 3 is going to be for the Aqua Stat on the tank. That is going to control the zone valve, the 3/4 inch zone valve that I put in. That Aqua Stat is going to control the zone just like a thermostat would. So we'll put it right where the thermostat goes. So here's the Aqua Stat. It's really simple. On the side here is a dial. You can see it's got a temperature setting on it. I don't know, maybe you can't see that, but it says 120 right there. Right now I have it at about 130. I just set it like that temporarily though. I had it actually at 110. I just wanted to turn it up so it would kick on the boiler. But so all it is a switch. Once it gets down to about 100 degrees, it'll make these 2 contact each other and it'll turn on the boiler, which will also in this case turn on the zone valve that I set up on that 3/4 PAX line. And then when it gets up to whatever temperature you have it set on, like 130, then it'll disconnect these 2, which will disconnect the boiler, it'll shut it off, and it'll shut off the zone valve. Very simple the way this works. I'm gonna probably end up putting what they call hydrostat in here, which is more like an electronic digital version that's like got Wi-Fi and all kinds of sweet programmable options in it. But for right now, this does the trick. And remember, all this does is tell the temperature of the tank to the boiler, tell it to turn on and heat it up or not. That's all it does. It's very simple. So zone 1 is the downstairs fan coils or the backup heat. Zone 2 is the upstairs fan coils. Zone 3 is going to be for the zone valve that opens up the PEX going to the tank to heat it up. So pretty simple. So now I just got to give this 120 volts right here on this transformer. That powers everything here. That gives these actuators 24 volts, not just an end switch, which is just a switch on and off. This actually gives it 24 volts because of that transformer, as well as this. This has a little motor in it that needs 24 volts, so it gets that from this as well. This, you can't just switch these together and it switches on. You got to give it some power, 24 volts. I probably should have laid this out a little bit better. I wasn't really intending on using this zone valve here, but it'd be nice if they went right into here, but they're not long enough. So I'm gonna have to splice this together and then extend it into there and then hook that into zone 3. This is for the zone valves right here. This gives them 24 volts. 18 gauge thermostat wire. These are solder seal wire connectors. So this is the red wires from the zone valve, which basically just gives it a switch on and off, lets it pass through some current. When I turn the power on this switch, it should power up both of these control centers here. Okay. So you can already see zone 3 is calling for something to happen. Just to show you what I'm working with here, this is my combination boiler and domestic hot water heater. So try to give you a rundown. It's kind of not really that organized, but this is the supply for the heat. This is the hot water, the domestic hot water right here. This is the cold water coming in. This is the return for the heat. You can see I got a pressure gauge right there. I got a feed valve right there. This is a condensing unit, which means it's really efficient. I think it's like 93 or 94% efficient. This is run off of natural gas. I got a 3-inch flue on it, and this is 200,000 BTUs. So that's a lot of power behind this. Right here is kind of like my control for it. On the left is the temperature for the heat, and on the right is the temperature for the domestic hot water. I have it set on 110. And in the top right hand number is the temperature in this room, which this is like upstairs from where you guys were seeing before. This is like a little utility room up here, just to make sure if I was in a flood that this boiler wouldn't end up underwater. That's why I didn't put it in the basement. So if this boiler had a 1-inch line coming out, I would have kept that all the way to the manifold, and I would have got a 1-inch manifold, but it doesn't. It only has 3/4. But 3/4 has a lot of flow, and 200,000 BTUs, I don't think you can get even close to that through a 3/4 inch PEX line, but it'll get all I need for this house anyways. My heat loss for this house is about 30,000 BTUs. So if you were to jump these two wires right here, this is a switch, the unit would turn on, and then it's got its own circulator pump inside of it, so it circulates the water down to that manifold that you guys saw. So right now I have no zones on, but if you go over and select the Aqua Stat to a little bit hotter, I'm going to show you. This is going to click, and zone 3 is on, and zone valve is on. So now I'll turn it off. That's it turning off. Now this is off. So that works just like a thermostat. That's why it's called an Aqua Stat. Just it senses the temperature inside the tank instead of inside your house. So zone 2 is my upstairs. I'm probably not going to see that turn on for a long time because it's not really cold enough. That only turns on when it's cold. And then zone 1 is going to be my backup heat for downstairs. That also is not going to turn on for a long time because the radiant heat's going to take care of it. So there is the system. So you heard that thermostat kick on. That kicked on zone 1 on this switching relay. That activates that pump. So now this loop is active. You can see the flow meters. Now you can adjust these, like there's less flow in this one, which I set like that because this is the loop that's above us in this room right here. This room is a little bit smaller, the loop is a little bit smaller than the living room. Also, this entire panel puts out a lot of heat. That tank puts out a little bit of heat. Everything there puts out a little bit of heat. And the incoming lines right here put out some heat. So we just overall need less heat in this room. So that's why I turned down the flow on that one. And then that way it pumps up the flow a little bit on these ones, which is living room and kitchen. So right now all the loops are running and you can barely hear anything. That's wonderful. You can actually hear my freezer in the background. It's louder than that pump is, and this whole manifold. So right now I'm sending out 110 degrees to my loops, and my return is only at about 75 right now. That's because it just kicked on. So overall I'm looking for a delta T of about 15 degrees, which means 15-degree difference between them after they're running for a little while. So the way I'm going to control these valves right here, I think I mentioned it before, was that when the downstairs is calling for heat, the primary heat is going to be these loops, and then I'm going to put my backup heat as the fan coils, which is these loops right here, and also this one too once I get those fittings. And so basically, if you're calling for heat at 68 degrees there and you're only at 66 degrees or whatever you set it at, then the fan coils will kick in to kick up that temperature, and then this will maintain it. So you have to get a thermostat with multiple stages to do that. At first I didn't know that, and I was going to run 2 thermostats and just run the loops at 2 degrees higher than the fan coils, but I discovered that you can use a 2-stage or a multi-stage thermostat and do the same thing just with 1 thermostat. So that's how I have it set up. And then the upstairs, that'll just call for that when it needs it. And I already have a thermostat up there. But it's nice that these are separated now, because before all 3 of these loops were like teed together, and so they would always run. And so you would get heat in some places and not the other. And you wouldn't have that much flow because you're only getting a 1/2 inch flow from the boiler to everything all at once. Now you're separated, so even if both zones are calling for heat, you're still getting 3/4 to 1/2 inch, 1/2 inch, and 1/2 inch. So you're still getting a lot more flow. Even if the zones weren't separated, the manifold separates them so that they get more flow. Plus I have control of them now too. I have control of the flow. Which that pump inside of the boiler is pretty strong. A lot stronger than that one. So on this thermal imager, you can see the lighter the color, the hotter it is, and the bluer or the darker the color, the colder it is. So you can see my incoming temperature is Celsius, of course. So you can see my outgoing temperature for the primary loop is like 120 something, and incoming it is, well, it's hard to tell, that's what it is. You can see that tank is pretty well insulated. It's just the pipe going out that's got some heat. There's some heat up there, and there's all my radiant heat loops. So right now that one's running at about 80 degrees, 78, but it just turned on, so it's going to warm up. So that's what that looks like. So this is in my bathroom here. You can see the floor is warming up. It just turned on about 5 minutes ago though. So a better example would be once it's on for a little while. Radiant heat takes a little while to warm up. But you can definitely tell it's doing something. And see that cold spot right there? That's this spot right here. And I didn't put a loop in there. It was really hard to get over there, so I didn't end up putting a loop there. So that's that blue spot over there. Which I'm kind of kicking myself for doing, but it is what it is. That's about the only spot I really didn't get that I kind of wanted to. Even the tub, which may not show up because it's insulated on the bottom, but even that I put a little heat underneath that. That's always nice. It's getting a little bit hotter. Those plates will also span the heat out so it's not strips of heat. Alright guys, so I could have shown you a little bit more with the thermostats and a bunch of different details, but I think this video is getting kind of long. So I had fun doing this. It's something I've wanted to do for a long time, and I started collecting the parts a few months ago in anticipation to do it. And I'm going to be selling my house really soon, so I got a bunch of projects on this house that I need to do. And it's been raining out for the last week, that's why I chose to do this instead of working on my new house. So now it's done, it's checked off the list. I just need to tidy up the electric a little bit. Tidy up the electric here. I have a lot of miscellaneous stuff, like all kinds of wires hanging down now because I took everything down so that I could get these loops in. So now let me put everything back and clean up the mess, and this will be all ready for its new owner. I thought this was really cool because of the Indirect tank. I'm going to have the same exact setup at my new house, and I'm going to have a geothermal system that powers it instead of a boiler. And the nice thing about that is I'm going to also have cooling too. So this tank is insulated, so you can actually use it for chilled water too. In this house I actually set it up for air conditioning because I was actually going to install a geothermal system on it. So this fan coil right here has a drip pan on the bottom for condensation, and it's right there. So there's a drip pan drain, one right there and one right there, and it's all insulated. I did all my ductwork that's concealed inside the walls. I put insulation on that, and so down here all I would need to do to run air conditioning is just insulate like this part right here and those parts right there, and then everything is insulated, and then I can run my cooling. But I'm not going to do that. That's definitely for the next owner. If they want to, they can put an air to water chiller on. The fan coils will take care of the cooling, and the radiant loops will be shut off in the summertime because you don't want to cool with those because then you end up with condensation. So you just run separate loop to the fan coils, insulate all the pipes, insulate all the ductwork. That way the second floor, all it needs is a couple pipes going to it, and I have air conditioning. The geothermal unit has a reversing valve, so you can do cooling and heating both, and you get a special thermostat that will switch between them. One thing I need to add to this system, because I took that other valve off right here, that one had a backflow preventer on it, so now this one doesn't. So I have it shut off right now because it doesn't even need any water. See, if it needed water, when I turned it on you'd hear water gushing, but it doesn't. It's 12 psi, so it's happy. So I'll keep that shut off for now. I'm going to order a separate backflow preventer and put it right here. That way water can't get backed up and go back into my domestic water, which would contaminate it. I'm also going to insulate these floors with at least the bubble wrap, the reflective bubble wrap stuff. That definitely helps to keep the heat from coming down into the basement so much. But at the same time, I don't want to fully insulate it because I do want to heat my basement as well. So I'm basically heating the first floor and the basement at the same time. If I turn up the speed on the pump, that's medium and that's high. You might be able to hear it through the GoPro, but I don't need that much flow. I'll watch the flow meters when I'm switching it. So that's on low now. But With low, I'm still getting 0.8 gallons a minute on those two loops and about 0.5 on that loop, which is all I need. I don't need to turn that up. If I was going to have different zones on this manifold, I would probably get an ECM pump, but because this is all one zone and 3 loops, I can control it by just going over and hitting the switch. When it gets really cold, maybe I'll turn it up to medium, get the flow going through there a little faster. These plates are kind of like the economy version of the plates. There's a better version available where they snap in from the bottom, so you put them up first and then you run your pipe and you snap it in. They're much thicker aluminum. They do transfer heat faster and they are nicer, but they're like 5 times the cost. So let's talk about the cost while we're at it too. Everything that you see here is about $1,500. That's including the tank, you know, the manifolds, all the PEX, all the fittings, the plates. Everything that you see here is about $1,500. Maybe a little bit more than that because I kind of lost track of the fittings, but I also have some to return. So let's just say at the most $2 grand. That's without the boiler. And since I don't know really what I'm doing, this was a good week worth of work with one person. With 2 people, it's about 3 days maybe. I also need to add a Y strainer somewhere in the line here, just so that if there's any sediment or if there's any debris in the lines, basically you have a Y pipe coming down and it'll drop down to the bottom of that, and then you won't keep circulating it around. And they have a little thing where you can take it out and clean it. And the reason why I was never in a rush to install this before is because I always used a wood stove. So my fan coils would kick on in the morning when the wood stove was kind of dying down, and it would kick the heat on in the morning. And when it got really cold out, the fan coils would also help supplement the heat. But for the most part, I always ran my wood stove because I always have wood laying around for free. So I was always not too worried about the heat in the house because I'm always here. But now I'm going to be actually staying over at the property pretty soon, working on the house. And I need a system that can just keep running while I'm not here. These fan coils were just not able to keep up if you don't have any other kind of heat. If you're just using the fan coils, it just wasn't enough. It might be now because they're separated, so there's a lot more flow through them now and a lot more heat coming out of them. But the radiant loops is what's going to run all the time, and then these will kick on when they need to as a backup heat. Also, my son Noah, he's like a super daredevil, and I kind of don't trust him around the stove. My son Caden was never a problem around the stove. He instantly learned that it was hot and not to go near it. But Noah, he just like really tests everything. So we just don't want to even run the wood stove. And we're on our way out from this house, so that kind of works out anyways. We'll just use the radiant heat, and basically that will take over for the stove. Alright guys, so I had fun doing this install, and I know it's a lot to take in. But if you're ever installing one of these, this might be a way to go. I'm not sure. It might differ for you. This is just how I did it. This is not really a how-to video. It does give you ideas about what you can do if you want to, all the different options. And there's so many more options, like outdoor reset you can use to be more efficient. There's just a bunch of different things that you could add on to this system to make it a lot better. And if I was living here for a while, I would actually definitely consider chilled water so that I can have basically central air. So that's it for now guys, and I'll see you on some more videos for this house and building my new house.